Hello.
Hi, Muskan.
Oh, finally, in biology, we finally got to the endocrine, etc., etc.
Okay.
Till this day, I still don't know I'm understanding the endocrine system, the brain, but I still will not know the homostasis.
I mean, what you didn't understand?
I just, I just don't get the main thing. Like, I don't understand how that relates to like everything else.
Oh,
Like I'm
relates. I mean,
understanding the nervous system and the brain and how that all correlates and works. But then when it
uh-huh.
comes to conversations, my mind goes blank. It doesn't understand the main thing, so I know that on the exam I will, yeah.
No, wait, let me get down to this. I mean, you're not able to understand how homeostasis is connected with this nervous system.
Yeah.
You mean to say that?
Yes.
Oh,
How it's connected with everything. So
okay.
I'm kind of dying on that.
Let me jump in. Okay, and okay, that's of course bio. What happened in chemistry?
Oh, in chemistry, so we got this one so we got our functional groups,
Uh-huh.
and then
Okay.
we finally went into the alkane,
Can I
alkynes,
get to see that
alkenes.
once again?
Can you, can you see that?
Okay. Yes. I got it. Yes.
Yeah.
Okay.
So we got that. And then I think she wanted us to and then she gave us like this paper.
Okay.
And then she wanted
Uh-huh.
us to like draw, like,
Yes.
because they're how the branches
The
work.
cyclostructures with the branches. Right.
Yeah.
Mm-hmm.
And I kind of understood it, but when it came to the naming, like there was three branches, and then one of the like, what is it? Like, what's the bottom thing called? Like the carbon, right? The carbon's the
Okay.
bottom one, and then the branches are like the hydrogens or whatever it is.
Mm-hmm. Mm-hmm.
So there's only one carbon, so it'll obviously end with like it'll be an alkane. And
Mm-hmm.
then she counts them really weirdly. Like if you go onto the PowerPoint,
1 sec. Let me pull it out.
let me open that one up
One
as well.
second. 1 second. Where am I? Here's the PowerPoint. 1 sec. Okay.
And then like on if you just scroll down to the next like lesson, like it should have
Oh, this.
uh one more down. No, up. It has like the numbers on them.
Mm-hmm. I got it.
Wait, I think. Yeah, wait,
This
that
one.
one.
Right.
Yeah. So she was
Okay.
explaining
Yes.
3-methylbutane,
Yes.
and but then how there's like just three of those, but then she's
Mm-hmm.
counting them
Mm-hmm.
as 1, 2,
Mm-hmm.
3, 4, and I was like, then why is it three?
Mm-hmm.
And then
Okay.
I was like, what? It didn't make any sense. And then she's pulling up methyl, and I was like, where are you getting that from?
Okay. 1 sec. Should I pull out another one here?
Like I'm really lost on how she's actually like naming these.
Okay. Now, before actually you jump into that, you need to know the prefixes correctly.
Okay.
Okay, because all depends on this. Like, how will you name it? It depends on the number of carbons present. If it's like only one carbon, then it's meth, then eth, three carbons prop, four carbons but, okay, five
But in
pent,
that one,
and
there
then
was
so
only
on.
one carbon.
Yes.
The bottom
So,
thing is going to be the carbon, and the top things that are going like that is going to be hydrogens,
mhm,
right?
yes. Let
Okay.
me pull out a structure.
And she said we're going to need to know like 10, up until 10.
Yes, you have to know it till 10. Okay, let me give you some examples so that you'll be able to know it. One sec. There we go. Chemistry of compounds. Yes. Now there are rules for this actually.
Yes.
Let me shut this down, pull up the whiteboard. Here we are. So for instance, if I, let me give an example for this. CH3, CH. I have a CH again, and then CH3. And then I have two chlorines here. Fine.
Yes.
Now, this is called as a root chain.
Okay.
What do we call it? The root chain. Okay, this is a root. Now, what kind of bonds can you actually find between these?
CH bonds, carbon.
No. What kind of,
Hydrocarbon?
like, are there single bonds, or double bonds, or triple
Oh,
bonds?
single.
Single. So
Yeah.
that must be,
Alkanes.
you got that?
Yeah.
You need to first find this out. Okay.
Okay.
Now, there are some branched structures here. Okay. Now, if you see, I have a chain of 4 carbons here. And if you see the second and the third, if I count from left, if I assume this to be 1, 2, 3, and 4, okay.
Yeah.
So you see chlorines are being branched with the second and third one. Now you must be wondering, why should I count it from the left itself? Why can't I count it from the right?
Yeah.
1, 2, 3, 4. Now that you count from any side, it's going to be 2 and 3 where chlorines are attached. It's not going to make a difference. Yes. Suppose in case I do not have a chlorine here, then you're going to start where the branch structure will have the least number. So like 1, 2, 3, 4. If I start from the right, 1, 2, 3, and 4. So which one should I assume? I mean, which one should I follow? This one or this one? The first one.
Oh.
Why? Because we are going to look out for the branch structure which has got the least value, 1 and 2. Because if I suppose, assume that this is not there. Okay, if I start from here, from right to left, the branch structure will be at 3.
Okay.
Okay, and if I start from the left, the branch structure would be at the second one. So the criteria here is you will be starting from the least position. Understood?
Yep.
Okay, but now that in this example, you had 2 chlorines. Okay, you start from either sides, it is still going to be the same. It's not going to make much of a difference. Understood?
Yeah.
Now, how many carbons do I have here?
You've got 1, 2, 3, 4, 5, 6.
No. These 2 are chlorines.
Oh, then
So,
4.
how many? 4 carbons. What do you
Yes.
call a 4 carbon atom in alkanes? If it's 4.
Aromatic.
No. If there are 4 carbons, what is the prefix you're going to give it?
Mono, di, tri.
No. 1
What?
carbon meth, 2 carbons eth, 3 carbons prop, 4 carbons bute, 5 carbons pent,
Oh.
6 carbons hex. I think you got that?
So now it's no longer mono, di, tri.
Yes, because the chain length will be indicated I mean, you'll have to name it by using the prefixes, depending on the number of carbons in it. So how many carbons do I have here?
4.
I have 4 carbons. So it has to be a butane. That's solved.
Yes.
Is that understood? Now tell me, where are the chlorines attached?
Chlorines are attached to the bottom.
No, I know it's attached to the bottom, but which one? Number what?
Number 2 and 3.
That's done. So 2, 3, understood?
Yeah.
2, 3. How many chlorines do I have?
You've got 2.
2 chlorines. So I'm going to write as dichloro.
So why is this one dot? Oh, because there's no carbon.
Dichlorobutane. So I'm going to call this 2,3 dichlorobutane.
Oh. Okay.
I'll give another example for this. Okay. Another example. Don't worry.
So we use prefixes only for the carbon, hydrogen,
exactly. Carbons.
hydrocarbon.
Forget about hydrogens. Carbons. Number
Only
of carbons.
carbon.
Yes.
Okay.
Okay.
Only carbons. Everything else we use the di, tri, whatever they're called.
Yes. Now, depending on where the branch structures are. Okay. Now, for
Does that matter?
instance, if I pull out another one, CH3, CH, then I have a double bond, CH single bond C, then a triple bond CH. Okay. Now, there are no branch structures in this. Okay. That's for sure. There are no branches at all. Now, what is the highest carbon bond here?
It is
A
triple.
single bond or a triple bond or double bond? What is it?
It's triple.
It's a triple bond, right?
Yeah.
Got that point?
Yeah.
Now,
Oh, no.
so what are triple bonds? How do you name them? What are the, if the
They
single bond
are
is alkane, if it's
alkynes.
yes, it's an alkyne, right?
Yeah.
Okay. And do we have double bonds as well here?
Yes.
Where do we have a double bond?
Between 2 hydrocarbons.
Yes, between that. That's at the third. That's at the third position. Now you must be wondering, sir, how do I name these number these positions? So I'll be starting the numbering from the biggest bond. That is a triple bond being here.
What
We'll
if it's in the
start from
middle?
here. What is it in the?
What if the triple bond's in the middle?
There are rules for that as well.
Oh.
So let me start with the basic ones. Okay. So I'm going to number it like this. Okay. Got that? Now, how
Yeah.
many carbons do I have?
You have 1, 2, 3, 4, 5.
5
Mhm.
carbons, right? So 5
Yeah.
carbons means what?
It's a penta.
It's pent. Okay. Pent. Now, I have a double bond here.
Yes.
So what are double bonds called as?
Alkenes.
Alkenes. Where are the alkenes? At the third position. So this becomes a pentene.
3 ene.
Yes. And what do I have here?
A triple
A triple bond. So I'll put a 1 here and put an ine. That is YNE. So this is how you number it.
Pent 3 ene.
In
1
ine. Exactly.
What?
Okay.
That's
So,
so messed up.
yes, this is a polyfunctional compound. Okay. Yes. So I'll give you one more. Do you have these what do you say? The functional group chart, right?
Yes.
Yes. Okay.
I
Keep
don't
it
know how to
handy.
use it, but I do
No, I'll
have.
tell you. I'll tell you. Let me pull out another one. These ones are very easy. Once you get used to that, how to name it. Okay, that's going to be very, very easy to. It doesn't take much time. I'm gonna have a CH.
lot
I
of
have a CH2 here. Then again, I have an OH. Then I should have the branch structure here. Yes. Now, in the functional groups, if you just look at the book or in the cheat sheet was given to you, Can you find anything with OH? Is that the same sheet that's in
Alcohol.
the alcohol? Okay.
That's R O H.
All OL, right?
Yeah.
In the N. Okay. I think even I have it here. Is it from the one which is in
Functional.
the mhm,
It's a
in
halogen.
the-
Yeah, that's on.
no, is it same chart which is also in
Yeah.
the
It should be in there. The same one, exact same.
PPTs? Yes, it's here. I got it. Okay, so I'll just stop the sharing and I'll just put you onto this over here. Now, if I can magnify this, yes, we can.
Oh no, this is different.
No, this is the same one, right?
Almost the same.
Now you have an OH over here, as you
Yeah.
can see this. So whenever you find this in that, what do you say? Whenever you have to name it, okay, along with the functional group. So whenever you have an OH, so the only thing you have to put in the end is OL.
OL.
So now, Muskan, try to understand. You have to learn these short forms.
What do you mean by like OL?
It's a shorter version of alcohol.
Oh, so like alkanes have the ANE.
ANE, yes, yes,
OL.
yes.
Okay.
Okay, I'll just go back to the whiteboard.
So I need to
again.
remember these ones as well. Okay.
Yes. Now tell me in this, okay, how many carbons do I have? Did I place
4.
it wrongly? 1 second, 1 second. I made a mistake
5.
here.
No, 4.
1 second, 1 second. Yes. Yeah. How many in all?
4 carbons.
4 carbons. So 4 carbons and all single bonds, right?
Yes.
So all single bonds means what do you call that?
Alkanes and
Alkane. Now there are 4 carbons. So what will it be?
meth.
No.
Wait, let me check this sheet.
Yeah, you can check that because you have to revise and memorize it. It's going to take a bit of time.
Yeah, I need to print out a sheet and then yeah. But let me find that.
It's
Is
there
it
in
on the
PPTs.
PowerPoint?
Yes, it is. PPT number 28.
Oh.
Not 28. No, not 28.
Oh, found it. It's 5, so pentane.
No, 4.
Butane.
Bute, right? So 4 is bute. So what will I name this here?
You will name it
Butane. It's going to be butane. Okay.
Yep.
Now, if you see the branch, we have branch structure at the end as well. So butane, and if you look at the what do you say, OH being attached. Now we're going to start this counting from here. 1, 2, 3, 4. Now you must be wondering, why did I start from the left side? I'm sorry, from the right side. Now, where the branch structures are, you're going to start from there.
Oh.
I mean, how close, what minimum number or minimum value it can take. Because if I start from here, it's going to be 3 and 4. But when I start from the right side, it's going to give me 1 and 2. So obviously,
so
I'm
you
going to start
want the
from
values to be as low
at the
as
minimum, the branch structure at the minimum value.
Okay.
Okay. So one thing is very clear here. It's going to be butane. Okay. And where are the OH attached?
In 2.
Even for the first one. Even for the first one as well. Isn't it? It's attached to the here it's attached to the first one and also to the second one.
Oh. Oh, because it's attached to one of the numbers, so they don't get a number themselves.
Yes. So this can be written as butane 1, 2 di, because there are 2. Even the earlier one, if you remember the first one which I did, chloro, dichloro. Okay.
Yeah.
So butane 1, 2 diol. That's it.
Diol.
All.
And do you only do di because that's the last number? So if it was like 3, then you do the mono?
Then no, it'll be tri.
Oh, let's try. Oops.
Okay.
So whatever the last
Yes.
number is, you're gonna go off by that
Yes,
number for any
exactly.
of the
Yes.
non-carbons. Okay.
Yes.
But the carbons go first, then the additional non-carbon, and then
Hmm.
that name, and then whatever it is.
Yes. Got that?
Yeah.
Mm,
So in alcohol, it's R, and then there's like a minus sign
mhm,
OH.
mhm,
So because it has OH, I can use
mhm.
that, right?
Yes.
And because it's the
Now,
same as single, like they're single bondedly OH.
mhm,
So like in aldehyde, they've got the OH, but that's not like completely single bondedly. Like they go through a
no.
whole like thing.
Yes,
So the structure needs to be the same. Okay, got it.
exactly. Now here, now you will tell me what this is. CH2, CH2, CH3. What will I
See,
name this?
you are going to name that
What is the first rule number one? What kind of bonds are there?
but
Or how
did
many
you
carbons are present?
you got four, so it's gonna be, but it's a single bond, so it's gonna be an
Yes.
alkyne.
Uh-huh.
And then you've got so
It's,
four
it's going to be an
carbon,
alkane. It's single bond.
alkane,
Yes.
single bonded.
Mm. No branched, no branches here.
So that means it is going to be, let me pull it up. Where is that slideshow? Butane.
That's it. Nothing else.
Oh, right, because there's an ane on it. Okay.
Okay.
So,
And
oh, so
can
that means for the chain length,
yes,
whatever it is, if they
that's
don't
it.
have an additional branch, then I just add on to like whatever.
Have
Oh,
you understood now? That's the reason I
yeah.
gave you only a plain one. Now, can you tell me the formula for butane?
It is C4H10.
C4H?
10.
See there, 3 plus 2, 5 plus 2, 7 and 3, 10. It's a butane. Got it?
And that. Yep.
Uh, Another easy one. Okay. Sometimes students take days and days to, master this. But I think
I
you're
can
just
see
beginning to
why.
get, I think you're just beginning to get hold of this.
I can see
Just
why they would struggle. I mean, half of our class is like kind of dying.
come on. Where will the counting start from?
It will start from the right.
Excuse
Left,
me,
left,
please.
left.
Left,
I
left,
meant
left,
I
left.
don't know my rights and left. I'll just let you know that.
No, tell me, do you want me to start from the star or you want me to start from the moon?
The star.
Okay, fine.
Thanks, thanks for that. And that's gonna be an
Mhm.
alkane.
It's going to be an alkane, fine.
So that's gonna be a butane, comma,
No,
two.
you will write the branched one first, the
Why?
branched chain first. Yes,
Okay, so that's just chlorine, right?
chloro. You will not say chlorine. In organic chemistry, when you write the IUPAC names, you'll have to say it as chloro.
For all of
So,
them?
yeah. So, where is the chlorine? Branch to the second one.
Yeah. So
So,
it'll
I'll
be
write
a
it as 2-chloro.
dye. Aren't I gonna write dye?
No, if there are two, then you just die.
So 2-chlorobutane. I think you're on mute. I cannot hear you. I cannot hear you, sir.
Able to hear me?
Yeah, now I am.
I
I don't know. Yeah.
There's some glitch in my microphone. Okay. Oh, so let me go back to that.
So
I was like,
2-chlorobutane.
yeah, exactly. 2-chloro.
But why will I not say the di?
When you have 2 chlorines. Here, this 2 means the chlorine is attached to the second hydrocarbon. Okay?
So that prefix is only used when there's actually multiple of them. And mono
Exactly.
never gets said because it's only one.
Yes.
Oh, okay, got it.
Let me put you through something else here.
What
Make it a
about when I have to
glitch.
draw this into a hexagon? Because into that hexagonal, like, weird structure.
Mhm.
Like, what, how would I draw that? Like, how would I?
No, first let us finish this part first. Okay.
Okay.
We will come to that as well, how to draw the structures. Okay. Sure. Oh my God. Two, CH2, CH2, OH. Come on.
CH2, 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 and then OH. Isn't this the same that what we did just before?
Yes. But this is, it has only one alcohol group.
Is and three. One, two, three, four. All right, OHs. What is OH? So I don't know if I can hear you again if you're talking.
No, no. I was
Okay.
actually speaking to my dad. Yeah.
What is OH?
Alcohol, OL.
Wait, is that just it? Or is it like alcoholoro or something like that as well?
Yes, we'll just write it as OL. But
Oh, okay.
now,
So I can just
yeah,
write it as okay then it's 2-OL butane.
Y2, Y2, Y2.
No, wait, it's 1-OL butane. But I don't know if the one gets written.
No,
So then
one
it's
gets
OL
written,
butane.
but one gets written, but it has to be because it's a what do you say, an alcoholic group. It has to be like butanol
Why is the structure changed for this one then?
because see, it's in line with the root. It's not been branched anywhere, and it's
So
the
when it's
first one.
branched somewhere, then I write it at the front.
Yes,
But then when it's not
exactly.
branched somewhere, I write it at the end. That's so
Yes.
dumb. That is really stupid. But okay.
Okay. Can you tell me what is the functional group for CHO or HO? CHO.
CHO?
Hmm.
Oh, al.
Exactly.
Yeah.
Okay. So, one sec.
What does the R mean? Does the R mean nothing?
Now, R is nothing but a functional group, which again, I'll tell you that one second. CH3, CH2, CH2, and then CHO. Come on, name this.
CH3. It's gonna be 1, 2, 3. What's 3? Pain. propane 1-al?
Propane? Why propane?
Because there's only 3 carbons.
Uh, did you read the functional group CHO or only HO?
CH3, CH,
No, no. In the
CHO.
sheet that's been given to you, the
Yes.
functional group sheet,
Yes.
just check if it is for HO or
It's C double bonded to O and then single bonded to H.
no. 1 second. No, 1 second. 1 second.
It's ethanol, isn't it? Like ethanol?
No, actually, I think I got the structure wrong. Alkene, alkene, alkyne, alcohol, ether, epoxide, alkane, aldehyde, amine, ester, cyanate, amine, aldehyde, ketone, thiol. Okay, yes.
But wouldn't it be that because it's connected to the branch? You can't write 1. So wouldn't it just be propane 1-al?
No, can you just send me the pic of that sheet, what you have with you? Is
Sure.
it the same one which is there in the PowerPoint?
No, because apparently that UPack or something, they changed it. So now it's different. Like the one on the PowerPoint, that PowerPoint got made like years and years ago. So they changed it so now it's like different. But I'll send that to you. Yep. Sent on WhatsApp.
Okay, 1 second. Nitro, ketone, aldehyde. Yeah, there's nothing with CHO.
I think that got removed or something. It would make sense.
It's not here. Because in CHO, what exactly happens here is C is also a carbon which is attached to HO actually.
C is also a carbon which is attached to HO, but isn't that
Yes.
how it's going on al as
Yes.
well?
So no, so even that carbon actually will be considered here. And this functional group will be an al. Okay, Al. So how many carbons here do we have right now? We have 4.
4 in total, yeah.
So butanal. That's what I want to name it. This is a little bit of.
That's what it would have been named, but aren't you gonna write
Yes.
the 1 like you did before, or is it because the
Mhm.
carbon is connected?
It's carbon connected. Just check out for COOH as well. COOH.
COOH. Yeah, carboxylic acid, so oic acid.
Yes, oic, exactly. Correct. So now I'll continue the same one.
Yep.
Now you will consider that carbon as well. And how do I name this now? 4 carbons. 4 carbons in the count.
Butylic acid.
No.
Why not?
Butane. And if it is COOH, what do you get?
Oh,
Anoic.
butanoic.
Yes.
Well, that's what I meant to say, but I just didn't get my spelling right though.
Oh.
Yeah. That's why I said butylic acid.
Okay, butanoic, fine.
So that one I'd finish the entire word and then get there. Okay. Great.
So basically you understood these. So
Yep.
I'll just make a worksheet for you. I mean, that's for tomorrow. Okay, which you will actually start naming. I'm give you pretty simpler ones to start with. Okay. Apart from that,
Unless if they have some weird meaning again, like, oh, if they're connected, then I have to do this, like the branches. Then I don't know about that.
no, you'll begin to get hold of it actually as you keep moving. Okay. Yes.
I hope so.
What's next? Okay. Now you had a doubt. How is homeostasis
Oh yeah,
related to? Yes. Now, what is the meaning of homeostasis?
that I don't know, and I can never
Homeostasis.
understand.
So it's an I think actually I remember telling you this. Okay.
You did tell me.
It's a state of steady internal chemical and physical conditions which are maintained by the living systems. Okay. So try to understand internal chemical and physical conditions.
Okay.
It's all based on that. Okay.
Yeah.
So what exactly happens? Because when you talk about homeostasis, it is actually a very, I mean, it's quite crucial when it comes to the survival of the organisms. Yeah, I remember telling you this. I mean, it's like you begin to resist to changes in the external environment. Okay. So it's a self-regulating process. Okay. That regulates the internal, variables that are needed to sustain life. Because that is how the nervous system interprets the changes outside.
Okay.
Like you touch a hot object, immediately move your hand out. Okay. So then what is involved in this? It's nothing but the entire nervous system comes into play. Okay.
Yeah.
And the entire regulation of homeostasis depends on three mechanisms. The first one, of course, is the effector. Then we have the receptor. Then we have the control center. Okay. So what exactly are these three? What are the receptors? Now, when I say receptors, they are all receptors which are connected to the largest organ in the body, which is the
Muscle or glands?
what is the
Oh,
largest organ?
skin.
The skin. Okay, so
Yeah.
all the receptors, see, a sensation, a feeling, or an external stimuli is felt on the skin. Understood? So all the receptors are present, or we can also call it as cutaneous receptors. Cutaneous is a term which is linked with skin. Okay, so as the name suggests, the receptor is a sensing component responsible for monitoring these, and not
So it
only
goes
monitoring, responding to changes in the external or internal environment.
so it goes from stimulus to receptors to control center to
Center, and then the
effector,
effector.
which is muscle or
Exactly.
glands, and then it goes to response.
Finish. That's it.
Okay.
This entire pathway, okay, the process comes under the subject of homeostasis.
Okay. Great.
Understood? Yes.
Great.
So what else did you learn in bio?
Basically everything you taught me last time. She
Okay.
pulled out the same example of the hot water thing. And then she's like,
Okay.
yeah, it goes straight to your spinal cord. And then that's how it's like, it signals your arms to move. And then you're like, oh.
Hmm.
But our whole bio class was dead. So no one really was listening, but still.
Okay.
And then we watched a video about like how body temperature, she's going on about body temperatures and how the body needs to stay at 37 degrees. Well, at least for
Yes.
us.
Yes.
And then it's like, we watched a video and then I'm pretty sure I have to rewatch the video because I wasn't paying attention, but still. It was mainly like the maintenance of like healthy blood pressure, functioning of immune system, water balance through natural, like, yeah. It's like everything that I'm guessing one of the organs does or something like that.
Okay.
Or it's like everything that happens while your body stays in temperature because if it, yeah,
Okay.
something
Do
to do
they
with that.
share? Do they share the videos?
Yeah, it's
I mean,
all
where
on
you
the
can have an
bio.
access. No, where you can have an access after school as well
Everything's on like it's
on the
either
portal.
YouTube or ClickView or
Okay. Okay. No,
but
I mean.
that one we also have our school login for that, so it's well.
Mhm.
But yeah. But and then I think next bio lesson we are cutting open a sheep's brain. I don't know why that's gonna help us, but apparently it is.
Sheep's brain.
Sheep's brain.
Yes,
I'm guessing that's the easiest one they could get from the butcher or something.
exactly.
But I don't know how
So
that's possible.
finally, it's a brain of a mammal, right? So
Oh yeah.
you'll be able to see the external structure of the brain and the color on the surface. Like I told you, it sometimes it's gray color on top, sometimes white. Gray
Isn't it something
because
pink? Most of the time,
no,
isn't it pink?
slightly grayish in color. Pink, of course, those are the blood vessels which actually give you a color of pink. But closely, if you just look at it very closely, it gives you a grayish appearance because of the cell body present on top. The same thing is exactly the opposite in the spinal cord. In the spinal cord, you have the white color on top because you have the axons which are myelinated, the myelin sheath. Okay.
Okay.
So then they explain about nerve cells and all that.
No, we haven't like gone into that. We're about to go into that
Okay,
after.
maybe yes.
We're gonna go
So
straight to the brain.
yes.
Today she was trying to, but everybody was like,
Okay.
"Yeah."
Yeah, but then again, uh, before actually getting into the what is the structure of brain, one needs to know that how the messages are what you say transmitted to the brain. How do they actually come to the brain? So it's again the involvement of nerve cells and neurons. So that's the
Okay.
reason, in fact, even I started off with brain, then I actually stopped at a certain point, I had to go back, explain the nerve cell to you, again come back to the brain. So
Yeah.
it becomes a bit easy with how the messages are actually transmitted. They're all electrical impulses.
Okay.
Okay, all the
Oh, could
transmission
you
of
send me the
messages.
notes on the bio? Because you had the notes, and then I just never.
Yes,
And
I will,
up
I
until
will.
today, can you send me
Mhm.
all of the recordings?
Yes,
And then I
sure,
will have to go through the chemistry
sure,
ones
sure.
now.